Hello, you're welcome to class. And let's look at this problem under rational functions. You have to sketch the function below and indicate the domain, range, vertical and horizontal asymptotes. Write the domain and range in set builder notation. Now, we have to list out all these, the domain, the range, vertical and horizontal asymptotes. Let's do that. Let's start with vertical asymptotes. So horizontal asymptotes, okay, the zeros, that's the same thing as x-intercept. So we also have the range, okay, the domain, the y-intercept. Okay, now how do we get the vertical asymptotes? All right, it is when this function is undefined. When this function is undefined, that is when we have the vertical asymptote. So how do we make this function to be undefined? It is only when the denominator here is 0. Okay, so in mathematics, once you have a fraction and the denominator is 0, so that fraction is undefined. So here now we can equate the denominator to 0. So we have 2x minus 7 is 0. So we have 2x equals to 7 and x will be what? 7 over 2. So vertical asymptote is x equals to 7 over 2. Okay, so now the next one is the horizontal asymptotes. How do you get that? Now you need to look at the polynomials we have here, the numerator and the denominator. This is a polynomial of order 1 and this is also a polynomial of order 1. So once you discover that they have the same order, now just divide the leading coefficients of the numerator by the leading coefficient of the denominator. Okay, now the leading coefficient of the numerator here is 5, while that of the denominator is 2. So that means that we have y equals to 5 over 2. That's going to be the horizontal asymptotes. Hope you get that. Now let's look at the zeros of this function. Okay, that is the same thing as x-intercept. So x-intercept is when y equals to 0. So you just equate this function to 0. All right, if you do that, so it's the same thing as saying 5x plus 10 equals to 0. Okay, so that's the same thing as 5x equals to minus 10 and x equals to minus 10 over 5. So x is what? X equals to minus 2. So that's going to be the 0. Okay, now how do we get the range and the domain? Now let's start with the range now. Okay, now the range is the set of all real number apart from the horizontal asymptotes. Okay, so if I want to write that, I will write is the set of all real number where y is not equals to 5 over 2. So that is going to be the range of this function. Now, what of the domain? Now, that is connected with the vertical asymptotes. Okay, so it's a set of real numbers as well, just like what we have here, where x is not equals to 7 over 2. So we have the set of real number where x is not equals to 7 over 2. Okay, and the last one we have here on the list, now you have to get the y-intercept. Now the y-intercept is when x is 0. So just plug in the value of x here. That is when x is 0, what's going to be the value of your function, which is the same thing as y here. So now what do we have? We have this to be when x is what? 0. So y will be minus 10 over 7. Okay, hope you understand that. So once you plug in 0 here, So this will turn to 0 and this turn to 0. So you are left with what? 10 over minus 7. Alright, now your zeros too can also be written as minus 2 comma 0. Still the same thing, so you can write it in order pair. So this can also be written as minus 2 comma 0. Still the same thing. Okay. All right. Now, so now the next thing is to write our domain and range in set builder notation, because that's what the question says. Now, how do we write our domain in set builder notation? So the domain is the set of x such that x equals to real number and x is not equals to 7 over 2. That is the domain. All right. So now let's look at the range. The range, let's say, is R, the range of the function, with the set of y such that y is equals to the real number and the y is not equals to the range. Range equals to 5 over 2. Okay, so this is the set notation. Okay, so now let us sketch the graph. Okay, all right, now you have to let's look at these points. You locate the point of the zeros, that is when x is 0, when x is minus 2, y is 0. So now that is going to be on the x-axis. So this point, this is the point. And also, now let's look at the y-intercept. So y-intercept is x is 0, y is minus 10 over 7. So that is around 1 point something, okay, minus 1 point something. So that is going to be around this place. Okay, just a sketch. All right. So now, before you draw the graph, now you need to draw the line of asymptotes. So it must be drawn. And let us look at it. Now the vertical asymptotes is 7 over 2. That is the same thing as what? 3.5. Now 3.5, that is x equals to 3.5. So 3.5 should be around this place. Okay, so now you have it this way. Okay, so now let's look at horizontal asymptotes. So that is y equals to 5 over 2, and that's the same thing as 2.5. Okay, so 2.5 should be around this place. Okay, so now this is the vertical, and this is the horizontal asymptotes. Now, to now draw the graph, now look at the 2 points that we have earlier. So now the curve looks like this. It will pass through these 2 points. So you bring it this way. Now it pass through this place, down, almost getting to the this vertical asymptote, but it's not going to touch it. The same thing also applies to this. So the curve will look like this. So that is the curve. Now we are going to have another curve here. Pick any number. It can be 5, it can be 6 and 7, but let's pick 4. Now that's a very small number that is closer. So now let's plug in value of 4 here. So we have y equals to 5 times 4 plus 10 over 2 times 4 plus minus 2 minus 7. Okay, so that's going to give you 20 plus 10. That is 30 over, now this is 8. 8 minus 7, that is 1. So that means it's going to be 30. Okay, so that means y is 30. So the point 30 is going to be at the top, somewhere here, up. Okay. So now, how do you sketch the graph on this side? So it's going to look like this. Okay, so if you go like this, now the idea is ensure that this line must not touch the line of asymptote, such a way that if I draw it up, it will not touch it. It will move very close to it. It will not touch it. As this one goes down, it will not touch this line of asymptote. Okay, so this is the graph of this function that we have here. So I want to believe you've learned one or two things. Thank you. Bye bye.